Welcome back to ARC Tutorials. This is a brand new series, a 4-part series on REST API top 40 interview question and answer series. These questions that I'm bringing are equally important for everybody who is into IT, developer, QA or full stack developer, as all these questions relate in some or the other way that you will work as part of your daily job. So let's go ahead, start this series. Before we start the question answer series, I would request you to get this entire presentation of 4-part series as an ebook PDF copy on REST API interview questions at arctutorials.gumroad.com. If you have any questions, write to me at surya.aradhya@gmail.com. Let's start the question answer series. Alright, the first question is, what is an API? An API stands for Application Programming Interface. What it basically means is a collection of functions, procedures, classes which allows us to communicate between two applications or libraries. An API is a software intermediary that enables two applications to communicate. If you are a UI developer, you will want to work with API to integrate that. If you are a backend developer, you might want to create APIs and expose them so that the front-end team can utilize them. Or in general, there could be microservices which can talk to each other. At the end of the day, in simple terms, an API, you can say that is a collection of functions and procedures which allows us to communicate between two applications or libraries. Some of the well-known public APIs, examples you can give, like Google Maps API, there is Amazon Advertising API, there is Twitter API, there is YouTube API. All these are RESTful APIs that are exposed. Now, I mentioned the word RESTful, right? So let's talk about that. What is REST? REST stands for Representational State Transfer. It's an architecture style based on HTTP protocol. What it basically does is it provides a lot of several guidelines and which allows us to build web services, and hence they are called RESTful APIs. The guidelines ensure that the request and resources are sent easily, they are developed efficiently, there is a standard naming of them, and how they communicate over the HTTP protocol. There are several defined HTTP methods that we utilize as part of REST. That's what you should explain about the basic understanding of REST. Now, I'll continue the same thing little bit. If you see, all these are terms are related, but you should know everything how it differs. What is a REST API? An API is a software to software interface that allows otherwise separate applications to interact and share data. A REST API, also called as RESTful API, is an API that follows REST principles. We will talk about the REST principles as we progress in the series. For now, all you should know is that whichever API that follows the REST principles is called as a RESTful API or a REST API. In REST API, all data are treated as resources. Okay, very important. Each one represented by a unique uniform resource identifier, or also called as URI. These are the fundamentals that everybody should be aware. Like I said, be it a developer, QA, backend developer, these are the concepts everybody must know. Now let's talk about RESTful API, some of the APIs that are exposed, like a Twitter API, right? It makes the Twitter tweets available from a certain profiles, right? If you look at YouTube API, from a particular channel, you can expose the APIs, etc. So those are called RESTful APIs. Now let's continue about API and talk what is API testing, right? Why is it important? When we talk about API testing is testing of APIs and its integration with the services. Here we test the entirety of an API from various different use cases. Like for example, whether the data that we are retrieving is in the correct format, whether the data is correct, whether it has all the required keys, whether it has all the expected data, whether is it secured, is it requiring authentication, is it requiring any certain headers, etc. The end-to-end aspects of testing that API is called as API testing. Now this is one of the commonly asked question. I mean, a lot of junior developers always come back and say, is API considered as software, right? So now a tricky question to answer, but in short, we can say that APIs are not really software. Okay, they are the interfaces. That's the right word for them. They are the interfaces which helps us in data exchange and functionality among different applications. An API provides access to data as well as functionality. Think of it like it's a request. You make a request to certain application. In return, it will give you data. That communication between two applications is called a API. So it's not really a software. We can call that it's a API interface. Okay, that remember this keyword. That's the interface. Now, again, a lot of times people try to confuse, the interviewers try to confuse, and they'll say, so what is the protocol that REST APIs use or depend on? All the REST APIs use HTTP protocol, okay, hypertext transfer protocol, that's used to communicate between different systems. REST APIs can be easily deployed over internet since HTTP is of the same protocol, right? So you can have a public accessible APIs, right? And that's why, because they are hosted on HTTP protocol and they use HTTP protocol, that's why it can be easily accessed via any web app interface. Now the next question, logical question they'll start asking you is about which are the HTTP request methods that are supported by REST. Okay. Now don't get carried away because there are a lot of other methods. I will talk about them. Any HTTP request method indicates an action that the client wants to perform through on a resource. Right? Everything here we call it as a resource in RESTful APIs. So any HTTP method that we use is trying to do a certain operation on a resource. There are mainly four primary requests. Okay. Again, there are many. I'll talk about them also. You should talk about get. Get means request a resource from the server. Post means create a new, submit a data and create a new resource. Put means updates an existing resource on the server. Delete, obviously by the name itself, it says delete a resource or remove a resource. Then there is also patch. Patch, what it does, it's an optional, it will update the optional fields, whereas put will entirely replace the content. I will cover that in the next question or so. So hold on to that thought. So when you're asked about the important or the main methods, HTTP methods, talk about get, post, put, delete, and patch. So what are CRUD operations, right? This is a common basic functionality that is performed on various modules or entities in the schema. CRUD stands for create, read, update, and delete. In short, it's called CRUD operation. Now, each of these actions correspond to a HTTP request. While for creation, you'll use the HTTP post method. For reading, you can use get. For updating, we'll use either put or patch. And for deleting, we'll use the delete HTTP request method. Now, what is the difference between put, post, and patch? This, if you are attending a job, this is a question that is often asked. Okay, irrespective whether you are a UI developer, backend, QA, or just getting started, junior developer, senior developer, this everybody should know. So let's go ahead and learn about them. A put request is used for both creating and updating a new object in the database. Now look at the text that I have made bold. If the resource already exists, then put will update the resource. So I told you we will use put to update only when it is available. Let's say for example you are trying to update user ID number 10. If user ID 10 exists, put method will update the details of that particular resource. If it is not found, it will go ahead and create one entry for you. Okay, so put can be used for both creating as well as updating. But as part of RESTful API, always make sure that you use put only for updating, never for creating. That's against the guideline. Now post. Post request is used for creating a new resource. That means here we are creating a new resource. That means we send the data to a API and it will absorb the data, do validation, sanity check, data check, and then it will create a new resource. whereas patch method is used to apply the partial modification to a resource. Let's say you want to only update few fields of a resource, then you will use patch. But put will every time replace the entire object, okay, entire structure, entire data. That's the main difference between put and patch. Patch will only do partial modification whatever objects you send, whereas put will replace the entire resource if it is found. If not, it will create one. I hope all these three are clear. Make sure that you stop here, read this text, make your fundamentals clear. Now, what are some of the drawbacks of REST? Right? While statelessness is a benefit of REST, it sometimes can be a disadvantage. The reason being that REST APIs do not preserve states. That means it cannot go back to the previous state or go to the next, like how we have in modern frameworks, some of the modern frameworks, state management. In other words, the server does not keep record of past interactions. Okay, if preserving state is necessary, then it falls on the client. Okay. Additionally, REST is less strict with its security measure than SOAP. Now, SOAP is basically it's an XML based thing, so it's more strict. REST is mostly on the JSON side, so which is not strict at all, and that's where you would see some of the errors or security lapse, all that. It also makes REST a poor choice for sending confidential information between servers and clients. Now, you cannot be transferring important information just via REST, right? You have to do a lot of encoding, base 64 encoding, etc., or have hidden secret passwords or tokens or keys in the backend, store it somewhere, read it from a bit bucket or S3 bucket or in a server vault, etc. Right? So you really don't. It's a drawback, right? You can't really send confidential information, and that's one of the drawbacks of REST. Again, REST is used pretty heavily with a lot of security layers and process layers, but you should be aware of some of the drawbacks that comes with REST. Now, what are some of the benefits of REST, right? Obviously, there are a lot of benefits. Some of the benefits that you should talk is REST is based around HTTP, right? Which means you don't need a separate infrastructure to host, to deploy, all that. It works well with the web HTTP protocol, so you can easily deploy over the web and can be accessible. REST uses simple method technologies like XML, JSON, right, which are easy to learn. Because REST communications are stateless, that means server and client are always decoupled. Once a request is made, once a response is sent, that's it, done. They are separate now. REST architecture is flexible enough to adapt a huge variety of use cases. Okay, and REST is lightweight architecture compared to other options like SOAP, etc. Applications which are built with REST are generally faster than those built with other APIs. Okay, since the processing, the return, usually it's more about on the performance side. They are generally easy, they are faster, and REST is easy to test in the browser with an API testing tool like Postman or Catalan Studio, etc. Alright, that brings us to the end of part 1 of this particular series on REST API Top 40 Interview Question Answer series. Um, Join me in the next episode. We will continue this 4-part series and we will make sure that you are well averse with everything that they may ask you about REST API in any interview. I wish you good luck. Check out the other parts so that you have continuity and you master the REST API interview questions. Thank you so much for joining. See you in the next episode. Back to ARC tutorials. This is REST API Top 40 Interview Question and Answer series. This is the part 2 of the series. Make sure that you have seen and checked out the first part where we covered around 12 questions. Let's get started with this series and part 2. Before we get started with the interview question answers, I'll request you to please get your PDF copy of this of this entire presentation of 4 parts as an ebook, and it's available at arctutorials.gumroad.com. If you have any questions, write to me at surya.aradhya@gmail.com. Thank you so much in advance. Alright, we'll continue with where we left. The first question in this part is, what are some of the principles of REST? Right? We talked in the part 1 we talked that any API that follows the principles of REST becomes a RESTful API. So let's learn what are those principles now. Any REST API must follow top 5 requirements. Okay, any API that fulfills these 5 requirements is called a REST API. The first and the foremost is the client server decoupling. The client and the server can only interact in a series of requests and responses. Clients will make a request, server will send response, that's it, deal done. There is no more further communication. Uniform interface. That means all communications between client and server follow the same protocol. And that protocol for REST, we call it HTTP, that is Hypertext Transfer Protocol. A uniform interface simplifies integrations because every application will be using the same language to request and send data. Stateless. The server do not store any information of the past request or the responses sent. Each request and response is treated as one single transaction or interaction. Okay, which reduces the server load. For one, because it's not saving your old data, history, logs, all that, and hence it improves the memory and improves performance. Layered system. Layers are servers that sit between client and API server. Okay, now there can be multiple APIs, right, which does a lot of functions like identifying spam, improving performance. um, Layers are modular. There can be a process layer, there can be an integration layer, there can be a security layer. So there can be multiple layered system. Okay, there is no one transaction which says client should call only one API and that's it. No, there can be multiple layers of APIs and how the data passes through. Cacheable. Server responses indicate whether or not the resource is cacheable. Okay, which means that clients can cache any resources to improve performance. Any API that follows all these 5 principles or requirements becomes a REST API. I hope it's clear. Please take a moment to read all the theory and documentation I've collected. This will really help you get your fundamentals right. Now, uh, the next logical question sometimes they ask is state some of the public APIs that you have used, or they'll talk about some of the public APIs that you are aware of. So you should be aware of these APIs just for testing purpose or even for just knowledge for purpose. So talk about Google Maps API, talk about Weather API, talk about YouTube API, talk about Twitter API. These are all publicly accessible APIs. If you have time, please do check them out. There is a lot more APIs like Instagram API, Facebook API. There is a JSON placeholder, fake RESTful APIs. So there are a lot of APIs available out there which are public and can be used for learning and training purposes. All right, now the next question is, what is messaging in the context of REST? In REST, messaging refers to the back and forth communication between the client and the API. Okay, client will make a request, server will give a response. That communication between client and server is referred to as messaging system. Okay, an interaction always starts with the client messaging the API with a HTTP request, and the API processes this request and then sends back a HTTP response with a status 200 or any status, failed, 4 of 4. So I'll cover about the statuses in the next couple of slides, but remember, interaction always starts with client making a request. That means you make a AJAX call or HTTP call, and server will receive that request, will process it and give back a HTTP response, and that is called messaging in the context of REST APIs. Share some of the advantages of API testing. Right now, again, this is something that is asked to everybody: developers, QA, full stack developer, DevOps. The reason is APIs are critical infrastructure to any application. Okay, they're extremely critical for reason that one wrong thing in the API can bring down the entire house. Okay, it can lead to a lot of damage. So hence we have to conduct a thorough API testing. API testing is less time consuming than functional testing. API can be performed in early stages of software development. It is cost effective. It is language independent and time effective, right? Most of the responses that we get from API server for APIs are plain JSON text or XML, which can be read by anybody, right? and we can perform an extensive testing without even knowledge of the backend, what's happening, how it's happening. So it's cost effective, long run, it's very beneficial. It will avoid a lot of damage if we do thorough API testing. List some differences between APIs and web services. Now, remember that. Again, this is a tricky question always asked to confuse developers. All web services are APIs. Okay, any web service is an API, but not all APIs are web services, because we learned that REST APIs needs to follow certain principles and guidelines. Only when they follow, they become RESTful APIs. Otherwise, they are just APIs and they are called web services. A web service might not contain all the specifications and cannot perform all the tasks that API would perform. A web service can use any style. It can be a REST API, it can be a SOAP, or it can be an XML RPC. It can be different styles other than REST. A web service always needs a network to operate, while APIs can operate over the internet because they are using REST. APIs use HTTP protocol, right? So these are some of the differences that you should talk about. Again, I'll say take few minutes or seconds to read these data, understand and get your concepts extremely clear. Now, what is a resource in REST context? Okay, in REST, every data at the server is labeled as a resource. So when we say we are posting data, that means we are creating a resource. When we say get method, that means we are requesting resources or data, right? Put means we are updating a resource. So a resource is an object with a type and a list of methods that can be used with it. Okay. A resource is identified with a uniform resource identifier, or URI in short. Okay. Clients access resources by including their URIs in HTTP request, right? So there is always a uniform resource identifier, URI, like an ID or something, or underscore ID, which uniquely identify a resource. There can never be two resources with the same primary ID. Okay, it will give you error. So those are the things that you should remember, like talk about person, or say give an example of a YouTube video, right? Every YouTube video will have a certain ID, which is what we put it in the URL. Yes, and that ID is unique because it will generate its URL, and that is how you can uniquely identify that particular video. So that's a uniform resource identifier. Say tweet ID, can be tweet ID, right? Or it can be, in your context you can talk that there is a person ID, which is always unique, or think of it in database like a primary key if you can want to correlate. I hope it's clear to you what is a resource. Now what is a URI, right? Let's continue a little bit and I'll talk in detail explaining you. URI stands for Uniform Resource Identifier. Using URI, we identify a resource on a web server. Each resource has its own unique URI, which means we need to include that in the HTTP request. The process of targeting a resource when its URI is called addressing. The format of URI is as follows. You will give HTTP here, colon, service name, let's say googlemaps.com or youtube.com/resource ID, which is the this is a resource type, say video/ID, the YouTube video ID. So that's the standard format that you would see everywhere. So think of it this way. This is the resource ID. That's nothing but a unique ID for that particular data. Okay, that for that particular resource. That's what is called as a URI, and definitely not URI, a movie. Okay, so yeah. Okay, name the 5 important principles of an API design. Now, the 5 important principles of API design are setup, execution, verification, reporting, and cleanup. Okay, so these are some of the 5 steps. Again, very basic definition, open definitions, which means it can vary from one framework to other, but these are some of the common principles that you will work with, like setup, execution, verification, reporting, and cleanup. If something was success, you send the response. If something failed, you do log, You do some cleanup, you don't make an entries in any other database or anywhere and then send back a failed status. So this is what happens: setup, execution, verification, reporting, and cleanup. Now, what does it mean for API to be stateless? Now, this is a question that even I ask a lot of times when I'm conducting an interview. So, statelessness is one of the key principles of REST architecture. In stateless communication, the server does not store any information about previous communications. Okay. In other words, the client and server do not know each other's state. Every request and its corresponding response is a unique interaction and a unique transaction. Statelessness simplifies client-server interactions because the server does not really rely on past requests. Okay, so think of it that way: there is no history, okay, of APIs. The client makes a request, server will give response. That's it. Nobody remembers anything what happened in the past, right? Or any log of it. Of course, there will be logs captured. That's different. But I'm saying the server or the APIs doesn't keep any track of it. Now, which markup languages are primarily used to represent resources in REST API? Okay, so there are two common languages that are, okay, markup is a wrong word here, but you understand it. The two common languages used for representing resources are XML, which is extensible markup language, and JSON, which is JavaScript object notation. Mostly enterprise complex applications still rely on XML because it's proprietary data and they want to secure that and they don't want the data to be available, easily accessible, all that. But if you look at the modern architectures of major companies or which are hosted via internet public APIs, they are all mostly on the JSON. So most likely, at least what I have worked in the past 6-8 years, mostly I've worked with JSON, so which is JavaScript object notation. So that's something that's used for representing the resources. Alright, that brings us to the end of part 2 of this series. I hope you're enjoying, I hope you're learning. If you have any queries, please drop them in the comment section. I'll be more than happy to answer them. We'll continue this series. In the next part, we'll learn about part 3 and learn about more interview questions. Thank you so much for supporting me till now. Please keep supporting further as well. I'll see you in the next episode. Take care and thank you. Welcome back to ARC Tutorials. This is REST API Top 40 Interview Questions and Answer Series. This is the third part of the series. If you haven't checked out the first two parts, make sure that you check them out so that you have continuity and you learn entirely all the questions. I've covered around 20-22 questions there. So let's get started with part 3 of the series today. Before we start with the questions, I'll request you to get this entire series, question answer series, this entire presentation as an ebook PDF copy at arctutorials.gumroad.com. If you have any questions, write to me at surya.aradhya@gmail.com. Thank you so much in advance. Alright, so let's start with the first question in this series. What is idempotent methods? Idempotent methods are methods that return the same outcome irrespective of how many times the same request has been made. These methods are important as they are common instances where client side might send out duplicate requests. Let's say you are trying to make a request to user/profile. When you pass that particular user one/profile, that means you're trying to request profile of user one, and it will always return you the same copy or the same outcome, right? Those methods are always called as idempotent methods. We use them so that we don't respond to duplicate requests or avoid any to implement caching or to even enhance the performance. These methods, remember that whenever the same input comes, the output is always same, and that's why they are called idempotent methods. Now, whenever we talked about a lot of HTTP requests from the client side, but what are some of the main parts of an HTTP request? An HTTP request will always have a status line, right? It includes what is the expected or method, right? What is the status of it with a number 200. It ranges from 200 to 300, 400, and 500. We'll cover that in later in the series. A request method which indicates what type of HTTP request method you're trying to perform. Get, post, put, delete, batch. It will have a URI, which means how do you uniquely identify a resource on the server? That's an important part of the request. The request will obviously have HTTP request headers, and optionally it may have the request body. Okay, when you talk about get calls, you don't really have any data that you send. That's optional. You can send, but that's optional. But in post and put, obviously you will require some data that you want to modify or create. So HTTP request body. These are some of the important parts of an HTTP request. Now, what are the main parts of a HTTP response then? Right? Responses are sent from these API to the client, and those have a lot of critical information like HTTP version, what version of HTTP it is using. It will have a status number, right? Indicates the status. Like again, 200 OK means 200 means it's OK. 500 means server unavailable, like that. Then you'll have a response headers, and you will have response body, which is nothing but the actual payload that we get from the API. So these are the main important parts of an HTTP response. State some HTTP response status codes that you might see working with an REST API. So I talked about statuses, right? Now 1xx, anything which has 100, 101, 104, that means the request was received, continuing process. Okay, it is processing. Anything in 200 series, 200 OK means the success was successfully received, understood, and gave you a output. 300, anything in 300, 304 mostly that you would see is a redirection. That means there are a lot of redirections that are taking place. 400 is mostly the client side errors. That means whether it's a bad syntax or a bad request cannot be fulfilled, etc. Anything that you see in the 500 series like 500, 504, all those, that means server has failed at some place and it is not giving you a valid response. So these are the 5 different statuses that you will see while working with REST API. Absolutely important for everybody, developer, QA, full stack, DevOps, everybody should be aware of these status codes. So go through these well. 1x means request was received, continuing process. 2xx, that is 200 series, will be successful. 300 series means redirection. 400 series means client error. 500 series means server error. Okay, remember that. Now, one of the most basic questions that is often asked is authentication. What is authentication process? Authentication is a process of validating the credentials like username, password, etc. to the system and making sure that the user has been identified in the system correctly. In API terms, authentication is used to protect the content over web. That means only valid users with valid credentials can access the API. There are different types of authentication mechanisms like OAuth, social login. You have the basic authentication where you pass username, password. The passwords are obviously base64 encoding created, so you can't really see the string, but you can send it in an encrypted format. You also have two-factor authentication wherein you send username, password, and then the API will send an OTP, right, to your mobile or an email, and then you validate that. So there are different ways of authentication. These are some of the things that I've listed. How does HTTP basic authentication work? While implementing basic authentication as part of APIs, the user must provide a username and password, which is then concatenated by the browser in the form of username password and perform base64 encoding on it. The encoded value is sent as the value for authorization header on every HTTP request from the browser. Again, this authorization header can differ in the new implementations with the new frameworks. Sometimes it's called a token, which is a combination of username and password. Sometimes we send username and password both. Right? Again, it depends from system to system, but these are some of the common practices. The credentials are encoded, which means you don't store it, the browser doesn't store it, they are not really like it's sent over HTTPS, right? So if they are not secure. So secure, and then there can be interceptors which can transform that request in different way. But this is a very generic overview of how authentication systems work, but you should be able to explain that in detail. Now, one of the important things when we talk about APIs is caching, right? So what is caching mechanism? It's a method of temporarily storing a copy of server response in a location. Okay, so that means in order to quickly retrieve it, let's say you're making some API calls frequently, same API calls with same data set, and you're getting the same outcome. So it makes sense that you cache them because next time you can serve from the cache, not again going to the server. So this decreases the server load. Caching also makes the applications run faster, right? Since you're not again going to server, processing the database, logical, everything, you're just getting from the cache. So it's much faster. Cache duration of a resource. Now this differs, okay? Now caching differs from system to systems, from a company to company. Some will store it for 30 days, some can store longer, and etc. That depends, okay, how long the cache you want to be, or you can even purge it at request, right? You can clean the cache whenever you want. So caching is a very important mechanism. It helps us store server response in a place for a certain duration of time, and we can serve our data from those cached data. Now you'll often hear the word payload. Okay, when you're working with APIs, you'll hear the word payload. Payload refers to the data in the body of a HTTP request or response messages. Whatever data that you send in HTTP body, right, body request or response, that becomes a payload. Payload can be in a JSON format or in XML format. Payloads are usually included as part of your HTTP request or response, right, when you use the methods like get, post, put, patch, and delete. Any data that you send is called a payload. Any data that you receive back from a response is also called a payload in simple terms. Alright, we talked a little bit about SOAP in the previous parts, so let's talk in detail about the difference between REST and SOAP. REST or and SOAP. SOAP stands for Simple Object Access Protocol, and these are two different approaches. Okay, there is no right or wrong. There are two different approaches, two ways to building APIs. SOAP is much more stricter in protocol, okay, than the REST APIs. REST is not a protocol; it's an architecture style, right? It's a guidelines. Any API that follows those guidelines becomes a REST API. SOAP is whereas more strict. There is a strict format of how you will follow the schema. REST APIs are much simpler to build, more lightweight, and generally faster than SOAP APIs. SOAP APIs are considered more secure than REST, okay, because it has its own infrastructure, it has its own way of processing, etc. REST allows caching of responses, okay, whereas every SOAP request is a brand new transaction and there is no caching mechanism in SOAP. SOAP encodes data in XML format, and that's why it is strict, right? Any small mistake in the XML format will screw up the entire XML. Whereas REST allows you to encode data in any format through XML or JSON, right? Whereas SOAP is strictly following the XML format, and that's why they are strict. That's why it's more, if any small errors in the XML format or schema, it would throw errors, whereas REST will not do that. Alright, there's also this question that is often asked to UI developers, especially, like what is the difference between a REST and AJAX, right? AJAX stands for asynchronous JavaScript, or in technical terms, it's called XML HTTP request object, right? So AJAX allows a web page to make a request to the server and update the page, right? So it's basically you make a XML HTTP request object and you get the response. AJAX is done when you call a request, when you make a request through AJAX, you might be utilizing an API, which is a REST API, right? So REST is most likely an API, whereas AJAX is from the client side, where you make a request, right? So AJAX sends the request to server with XML HTTP object, and the API that is called is a REST. So there are two different things. Think of AJAX like a client side, and REST is your API, which processes that request and gives the response back. Alright, that brings us to the end of part 4. In the next I'll cover part 5. Here it's written part 4, my bad. But in the next it will be the last episode, which is part 4. And this is part 3 that we have just completed. I hope you're following and enjoying this series. And if you have any questions, write to me in the comment section below. I'll be more than happy to help you. I hope you're enjoying this series and learning and preparing for that big interview. Let's join me in the next episode, part 4, where we'll complete this series. Thank you so much in advance. See you in the next episode. Welcome back to ARC Tutorials. This is REST API Top 40 Interview Question and Answer Series. This is the last part in this particular series, part 4. If you have missed out on the first 3 parts, make sure you check them out. I've covered around 33 questions there already, and the remaining I'll cover it in this part. Let's get started. But before we start with our questions, I'll request you to get your PDF copy of this entire presentation and the question answer series in a PDF format. You can get the ebook at arctutorials.gumroad.com. If you have any questions, write to me at surya.aradhya@gmail.com. Thank you in advance. Alright, so let's start with the first question in this part, which is list some of the tools that are used for testing APIs. Right? One of the There are many tools that are available for testing RESTful APIs, but the most I think preferred for developers, at least I think, is Postman tool, which I too use heavily. JMeter, there's another tool, and there is a Catalan Studio that's also available. So these are some of the popular tools that are used for API testing. Now, the general discussion when you go into an interview, right, they'll start asking you about your approach, your logical way of thinking. So the first question they may ask you is how to secure REST APIs, right? Because they're not as strict as SOAP APIs, right? We discussed that in the last episode. Because SOAP APIs are strictly based on XML, whereas REST APIs can have XML and can have JSON. And their SOAP APIs are much more stricter than REST APIs, and hence it's important that we secure the REST APIs correctly. Now, what are some of the good measures you can take to secure the APIs? For one, you should use a strong authentication and authorization mechanism. Okay, like token system, injecting headers, certain headers, timeout. Then there has to be a key that has to match with the provided one, and username, password, of course. There will be a strong encoding systems in place. There will be validation, right? Any request that comes even with a valid data has to be valid, right? Let's say a client makes a request with correct authorization and authentication, but we still need to make sure that our data is sanitized properly. Otherwise, it can be prone to a lot of attacks. Okay. Encryption, using encryption for data security, right? There are a lot of critical data, and there is data that needs to be massaged and made it into a certain format so that it's highly encrypted and cannot be decrypted back easily. So that's where you secure the data. Rate limits, right? Now, if you see Google Maps, Google API, or Twitter API, or YouTube API, Instagram API, they will allow you certain requests in per hour, right? You cannot just blindly keep on making requests or automate that flow and pull out all the data. You can't do that. All these APIs restrict you with number of requests per day or per hour and all that. So there is a rate limiting. That way you don't stress your server, right? If you don't put the rate limits, your server will go down in no time. Again, one of the last things that you can also do is sensitive information can be removed from the URIs, right? Don't put any sensitive information which can identify the customer, client, or data, or field, or an object. It should be generic. It should be just an alphanumeric string of 28 for 24 characters or 33 characters, whatever fits in your application. So these are some of the best practices to secure the REST APIs. Take a moment to go through each one of them, make it clear in your mind so that you can answer them when they ask you. Now, what are some of the main characteristics of REST, right? Again, we talked about this briefly in principles, right? We can correlate them here. REST uses HTTP protocol for all the communication, right? It happens over web, internet, which runs on HTTP. REST makes server resources available via URIs, right? Every resource that we want to work with at the backend has to have a unique URI. No two resources can have the same URI. REST is stateless. That means there is no mechanism of storing information about the past communications with the client. No history of requests or responses. REST uses GET to retrieve resources from a server, whereas other web services use POST, right? Now that again depends, right? So you can talk about the HTTP method supported by REST. You can talk about some of the RESTful characters of API, like the design principles we talked in the previous part. So those things you can talk as part of the characteristics of REST. Now, what is the difference between API testing and unit testing? Again, important one from a developer, QA, and full stack perspective. Unit testing is white box testing. That means you actually write code to test your logical function, methods, classes, etc. Whereas API is totally a black box testing. That means the person testing the API does not need to know anything technical. He will just pass the data that is expected and he'll see an output. Right? Even for the data that is wrong, he'll see a proper error message from the server. Whereas unit testing, we can run them in isolation, right? We can test each pieces in isolation. Let's say my functionality has 10 features. I can write 20 or 10 unit test scripts. I can run each test script separately in isolation. Whereas API has to be a complete API testing. You cannot test only few fields in one go and others like that. So that's the main difference between API testing and unit testing. And that unit testing applies to both server side as well as the client side, right? At the server side also we use Mocha, Zest to write or sign on. There are different frameworks that we can use to write unit test for Node.js, Express.js, or any other backend framework for that matter. But API testing will be done purely in tools like Postman, Catalan Studio, and the user does not need to know anything about the technical aspects of it. What is a pre-request script in Postman? This is something that is often asked too many times. If you see the Postman, you would see a tab here which says pre-request script. That means it's a script that runs before execution of a request. Think of it like an interceptor, right? Interceptor, what does it do? It before making a request, it will do this processing, this job, and then make a request. So remember, whenever you hear the word pre-request script or something, that means a script that runs before execution of a request. This is a screenshot from my Postman, so you can see the tab here. Again, you can put the scripts or the steps that you want to perform before you actually hit the send button. Okay. Now, how should we test the API security? Now again, there are many ways to security testing of APIs. Some of the things we discussed, like authentication, authorization, right? Whether the user is allowed to access the resources. Authentication means identify whether end user is correct or not, whether he is legal eligible or not to access our system via username, password, and those fields. Which options help to identify the type of API request? Now this is again a little bit more about HTTP request methods, right? Um, that will tell us what type of an API request it is. If you make a GET call, that means you're trying to request data from the server. If it's a POST, that means you're trying to submit data and create a new resource. PUT means you're trying to update an existing resource. Delete means you're trying to delete an existing resource. Now those are the things that will help us identify what type of API request it is, the HTTP methods. Now what are some of the challenges faced in API testing? Right now there are a lot of challenges that I'm sure QA team can also add something in the comment section, but API chaining or sequencing of the API calls cannot be really tested thoroughly, right? Like for example, you'll first call login API, then it has to go to dashboard, from there it has to go to profile. There are three different API calls, but you cannot test them in sequence, right? There is no way to sequence them. Then data, right? Data is a critical thing for API testing. You will have some happy path with correct data, you'll have some negative path with some incorrect data. Now those are limited, right? Because the permutation and combination can differ, and it can really be a game changer, because if you don't thoroughly test all the use cases with data combinations, your API can come down very easily. Now if there are frequent schema changes, right, at the back end, then API testing becomes a challenge, because you don't know when the schema changed and what the schema looks like new one, what the responses should be mapped accordingly, etc, etc. Access to database, right? Since API is more like a black box testing, we don't have any access, so there is no really cross-checking of data response, right? You get a response, how do you make sure that the response is correct and expected outcome, right? So that can be a challenge in some scenarios where you don't have access to really database, etc. So list down any other challenges that you know in the comment section. I'll be happy to learn from you. What must be checked when performing API testing? Right? In order to perform an API test, you must check some of these. You can talk about accuracy of data, right? Whether the response that we received is correct or not. Schema validation, whether the schema of the resource is correct or not. Check for the correct status codes that you're sending. If it's a 200 OK, it has to be 200 OK. It cannot be 500. Data type, validations, order, and completeness, right? Then authorization, authentication checks needs to be there. Implementation of response timeout. That means I called an API which is taking too long. It should time out, right? It should not continuously keep on waiting forever. Error codes, like proper error coding has to be there, 501, 502, 503, 504, or whatever that error codes are. Non-functional testing, like for example, how much your API can scale. That's a really challenge. That's again, you need to put it under stress testing, load testing, and make sure your API withstands all that load. There's also challenges and performing for security testing, right? Making sure that overall your API test is secured. So we need to make sure that we put correct checks in place so that security is there in place and nothing goes out of sync. Now, what kind of bugs does API testing find most commonly? Right? Again, this is a generic question that can be asked to anybody at even front-end developer, QA, whatever. The type of defects that are usually identified with APIs are the missing data, right? Missing or duplicate data in the response. And you fail to handle the error conditions gracefully. Some of the conditions will fail, and intermittently it will just fail without giving you proper messaging system or clean exit. Stress testing, that means how much load can your APIs can take. That's another yet a critical piece of building an API. Reliability, security, unused flags, unimplemented errors, inconsistent error handling, performance, multi-threaded issues. These are some of the common defects that you will come across in API testing, which are common. Okay, as you start building APIs, you will run into some or the other issues like this. But over a period of time, you make them stable, you make them scalable, and you make them reliable. Now, there is another thing that I wanted to cover, which is often asked, is what are options in REST APIs, right? You would see in the network call, you will see something called options call going, right? When you make a post request also, you'll see options. So what is that? It is an HTTP request method to fetch the supported HTTP methods. Okay, so that is where it will give. First, options will go and check what all HTTP methods are supported. Okay, and then choose the options in the REST API. This is also used for cross-origin resource sharing. Okay, that uses options and checks whether you are allowed to access that particular server and get the methods. If yes, then make the post or get or put or whatever it is. So usually you will see the first call going out is an options. And what does options do? It will fetch the supported HTTP methods. It, while some of the checks it will do is the coarse errors, right? Those that is checked in the options itself. I hope it's clear. If not, drop me a comment. I can add more content to it. All right, what are the common API errors that are often found, right? Some of the common APIs errors that even I make still are some of the missing module errors, documentation errors, parameter validation errors. So these are some of the common errors that developers will make at some or the other point while developing, and that's normal, so don't take too hard on yourself. But be aware that these are some of the commonly happening errors that you will see when you're developing it. Let's talk about the documentation parts of it, right? We talked about API development, we talked about REST, we talked about HTTP methods, testing. Let's talk about documentation, right? What are some of the available API documentation templates? So I think most of the developers, at least in my career, I've seen mostly using Swagger, right? Swagger docs. That's something that's becoming an industry standard. A lot of leading enterprises use Swagger to document all the APIs, their details, what type of REST method it is, what are the parameters it is expecting, etc. There are other things like FlatDoc, API Blueprint, RESTdoc, etc., which does something similar, which is basically documenting your API template. Alright, that was the last question, and that brings us to the end of this series, a four-part series. I've covered around 42 questions in the series. I hope you have learned and you are now comfortable answering any REST-based questions that we have covered, and you will be able to crack your dream interview and get the job. I wish you very all the best. You can get the entire PDF copy at arctutorials.gumroad.com. Happy learning. If you have any questions, write to me at surya.aradhya@gmail.com. Thank you so much. We'll see you again in some other series. Thank you.